Are we running? What tape number is this? This is tape number 6. Collins talking, page 28, section 11, 0, CSM Circumlunar operations. In general, CSM Circumlunar operations went very smoothly and there were no surprises. The spacecraft operated normally. It didn't have any failures. Navigation. Of course, there wasn't much navigation to be done. I did use P21 several times to pin down the location or the time of arrival at the meridian 150 degrees west, which was the prime meridian on the map, and it seemed very simple, easy thing to do to use P21 to get that information and to update the map. The map worked fine as far as the time tick marks. As long as you're in an orbit whose period is approximately 2 hours, the map is a useful tool in helping locate where you are over the ground. Landmark tracking. The operation of P22 itself was very easy. The procedures that I had condensed into a checklist on the LEB panel were more than adequate. I always went to P22 early and got auto optics cranked up and pointed at the landmark far in excess of 50-degree trunnion, which meant I sat there with a program alarm until such time as trunnion angle came down below 50, at which time I punched off the program alarm and the optics then began to track. I found that was an easy way to operate the system. I could, with the center couch removed, which I had the center couch underneath the left-hand couch for EVA. It was easy to move from the LEB up to the MDC, and I found that either window 2 or probably even preferably window number 3 could be used to give you an idea of where you were relative to the landing site. And I could look out either of those 2 windows and see all the landmarks approaching, and then when I got fairly close, all I had to do was leisurely wander down to the LEB, look through the optics, and be ready to mark. It was very simple. The problem was that I didn't know where the LEM was, nor did the ground know where the LEM was, and there is just too much real estate down there contained within the intended landing zone to scan on 1 or 2 or 3 or 4 passes. On each pass, I could do a decent job of scanning 1 or 2 grid squares on the expanded map. Now that map is the 1 to 100,000 map called LAM2, and they were giving me coordinates in grid square coordinate systems that were as much apart as 10 squares, indicating to me that they didn't really have much of a handle at all on where the LEM had landed, and as I say, it was just too large an area for me to visually scan. I used auto optics, and each time I looked at the area they suggested, but in no case did I ever see the LEM. I don't have any suggestions for future flights. It seems that you have to know with considerable accuracy where the LEM is before you can mark on it, and if you knew where it was that accurately, you wouldn't really need P22 to refine your estimate. I don't know what to say about that. Perhaps a different sun angle would yield the possibility of a flash of specular light off the LEM skin, giving you a clue, but I looked for flashes, never saw any. I looked for LEMs, never saw any, and so forth and so forth. Misfin worked fine. I was using auto react on the high gain antenna. It worked well. The ground was very conscientious in updating AOS and LOS times. I don't think that's really necessary if you're in a near nominal trajectory as we were. It's an easy thing to do if you have good comm, but if the comm is intermittent, you can waste 4 or 5 minutes trying to read back and forth AOS, LOS times, which really are not required anyway. And I think when the LEM is on the surface, the command module should sort of like a good child be seen and not heard, and the communications with it should take on sort of a negative reporting method. Plane change was not required. The plane change procedure of uplinking a new refs mat and gyro torquing the platform around to that new refs mat is a tedious procedure, and I'm not sure that the gyro torquing is the way to go. As a matter of fact, a few days before the flight, we abandoned that gyro torquing method in favor of course aligning to the new refs mat because of the fact that the gyro torquing took an excessive period of time and had no protection against gimbal lock, and we could not even predict in which direction the platform would gyro torque. At least that was the story we were given. I think for future flights, for example, Gordon has to make a plane change on Apollo 12. I think some thought should be given to the best procedure for doing that. In regard to plane changes during, well, I'll have another comment later. I'm disregarding it. Sleep attitude. All right, in sleep attitude, I think the procedure was worked out fairly well, except that I don't recall that any mention was made about deadbands. Now, the ground, I believe, in all cases wanted a 10-degree deadband, but this was something they just asked for in real time. And I think it would have saved some chatter over the radio and some, not confusion, but at least some chatter over the radio had all that stuff been worked out and put into the flight plan. Precisely what control mode and the little, the 4 or 5 disk key operations that are necessary to achieve a 10-degree deadband. Had they been printed right into the flight plan, I think that would have been a simpler way to go. Photography, I thought worked out well when I was in there by myself. The amount of photography I did, or the amount of time I devoted to the photography, was somewhat limited by the fact that I was doing P22 each and every pass. And this P22, of course, keeping the optics line of sight pointed at the surface was not compatible with good photography. So I probably would have spent more time taking pictures had it not been for the question about the LEM's landed location and the need for additional P22s. I did use the intervalometer. I'll have to wait and see how those pictures came out, but in general, I think that the command module should carry plenty of film, and I think the key to getting some good pictures from the command module is having the luxury of being able to expose lots of film without worrying about running out of film. Rest and eat periods were fine. I have no comment about those. Monitoring the lunar activity, there was some difficulty with the ground S-band relay. The pre-flight agreement was that all my transmissions would be relayed to the LEM, all the LEM's transmissions would be relayed to me, unless that mode of operation, because of systems failures or other problems, became too cluttered, at which time the ground was free to amputate that relay mode. However, in flight it did not work out that way. The relay was rarely enabled, and I'm gathering it was because of some ground switching problems, but I would have preferred to be receiving continuous S-band relay from the LEM, and I felt somewhat cut out of the loop, although it was in no way a safety problem. I just felt somewhat cut out of the loop during the extended periods of time when the relay was not in effect. Visual monitoring of the LEM. I did not use a monocular because I did not have the monocular. It had gone to the surface with the LEM, but I don't believe it would have been of any benefit in looking for the LEM. I think the sextant is a more powerful instrument, and God knows I tried with the sextant. Yeah, and much steadier. And it was simply not possible for me to find the LEM on the surface with the sextant. CO2 canister changing was the same as when 3 people were in there, no problem. Maneuvering to support liftoff was worked out well pre-flight, and I followed it that way. Of course, I couldn't see the LEM, but I did nonetheless go through the motions of maintaining the proper attitudes so that my radar transponder would be locked on if for no other reason. Or not locked on, but my radar transponder would be available in case the LEM wanted to lock on or whenever they did. And that's all I have on Section 11. I thought in general the CSM solo operations were fine. I have no comment on those. Of course, I'd had no systems problems, and therefore I was very happy with the operation of the command module, and I was pretty much at ease about going to sleep and leaving the command module unattended. That didn't bother me a bit, whereas I would have guessed pre-flight that it might have. And it might have if I'd had half a dozen failures prior to that time. But I believe that the same good luck would continue, and as a result I got fairly decent sleep that night. Okay, Section 12. Buzz, you want to start on that?
Yeah, why don't we wait till...
Section 12. Liftoff, rendezvous, and dock.
Well, somewhere in here, I guess... Oh, wait, right.
Feed water measurement was performed, and the numbers were performed passed to the ground. And I don't remember what they were, but basically, first we zeroed the scale, then we, with the bag on, empty bag on, and we took the bag off and reported the RCU weight with the RCU and not the bag on. Now we put the water in the bag and reported that weight. It's about a full bag of water.
Through all of this, I didn't have a real high confidence level of the accuracy of what we're doing.
It's roughly 1 full bag of feed water, which is a lot.
I would think that a volume measurement might be just as accurate.
That was the initial plan, a volume measurement, and that was discarded based on its accuracy.
It also seems to me that since we were, I guess the ground had concluded that the water level was lower in Lifeless, it would have seemed to me that that might have been the one to measure. But that wasn't the idea from the beginning, so I stuck with it. I think to evaluate consumption, they might have, since they had some indications anyway that the consumption was higher on mine, that it would have been better to verify that one. We'll see what we get on that. Well, we were given an update on consumables, and we've already talked about the sleep period, and I guess they were looking at your biomed during the rest period. As far as I know, we got up just about on schedule and started our activities. It very well might have been a good bit ahead of schedule, maybe a half an hour or something like that, since in a further desire to try and identify just what our position was, the ground wanted us to go through a P-22 radar track of the command module. Now, we had done this once, maybe twice in the simulator, and even though on the surface of it, it looked like a fairly involved task, once having run through it in the simulator, it's fairly straightforward, and it turned out to be quite a simple operation. Before doing this, we configured circuit breakers and went through a DSKY computer check. I'm not sure why it was felt we needed to do this. I have written down here that oh yeah, these were notes as to what we were to do, or how we were to handle a P-22 as an option 1, no update. And if we got a 503 alarm, we were to key in and proceed, and leave the tape meter in altitude rate so it wouldn't drive into the stops, as it would most likely if it were on range and range rate. It seemed to me that rather than telling us no update mode, I was looking for a choice to be made somewhere in P-22, and I couldn't find it, of course. We weren't that familiar with the program. It would have been much easier to say, do a verb 95 before starting it, because that's evidently what they meant. Anyway, we went through a LGC self-test and brought the AGs back up online, and then proceeded into the P-57. Now, I'd like to point out a few things on the previous day's P-57. I said before that the yaw left tended to move the one star that I wanted to use, Capella, out of the right rear detent. The sun was in the rear detent and generally obscured it right after touchdown. Even though it was not visible in the detent, its light level was sufficiently high so that no stars could be seen in the rear detent. The Earth was in the forward detent, and due to the yaw left, it was also in the right detent, just on the fringe, as was indicated by our star chart. It would be, and it obscured the right front detent from for any use on the stars. Now, for the P-57 before liftoff, the one before the P-22, since I guess maybe 18 hours had transpired, why the sun moved up in the field of view, as did all the rest of the stars. The Earth stayed the same. So the Earth obscured the forward detent and the right detent. The sun was now in the rear detent, well up into it, and for some reason it also obscured the left rear detent, which is the one I was counting on using with Rigel, because it's the one we'd used before. And I was quite surprised to discover this because the sun was not within more than 15 degrees of the total field of view. It did, however, somehow shine onto either the cone where it had been flattened off or some other place, but it completely obscured the left rear detent. So it really effectively left us with 2 out of the 6 detents to pick stars out of. And in looking at those 2 detents, there weren't any stars near the center, and of course the closer to the center of the detent you get, the greater the accuracy is. The day before we'd used Navi, and it wasn't particularly bright, so I went back and now could use Capella, but it was fairly close to the edge of the field of view. So we did a gravity 1-star alignment, and let's see, we got the first gravity alignment came up with 3 balls 10. Burp 32 gave us 4 balls 1. And we used a sequence of marking that involved an onboard averaging of 5 successive cursor readings, followed by depressing the mark button, and then 5 successive spiral readings that Neil would log down as I'd read them off, and then he would average these up, and then we'd put them in, and we'd use either spiral or cursor first, whichever appeared to be more convenient. And I think this averaging technique worked out better than letting the computer do it, because it would have amounted in a considerable rotating of the spiral and cursor of the reticle field back and forth to make one spiral, then a cursor, then a cursor, then a spiral, and do a recycle. There is that option, however, to do one or the other. This was a refsmat alignment. The torquing angles were fairly large. Star angle difference was 4 balls 7, which pre-flight was the expected value of a 2-star alignment. Torquing angles were very close to 0.7 in all 3 axes, which indicated that the platform did drift a fair amount during that time period. We then did the P-22, and I had hoped at that point to use the AGS to tell me where the command module was, but unfortunately we didn't update the AGS with the latest ping state vector, so it wasn't giving us good range and range rate. And I would recommend doing that if anyone does P-22 in the future, because you can't use the pings to tell you what the range and range rate are, and you can't use the radar because it's not going to lock on until it gets to 400 miles, but the AGS gives you very good indication as you're approaching that range. So we were a little misled, and I thought we were still well out of range when we finally got the lock on. And as the program's written, you just call it up before you designate back to the rear, and you call up the program before the command module gets to 400 miles, and it sits and waits, and when it gets less than 400, why, it locks on automatically, and you see the signal strength grow, and it starts to track, but it's in mode 2, so you don't see the needles doing anything. The cross pointers move, indicating that it's got rate drive going as it's trying to keep up with it. Since we didn't want to run the tape meter into the stops, we left it in altitude rate. So we really didn't have much of an indication that any good information was coming in other than signal strength. I guess the ground got the data on the downlink. The thing was that when it broke lock, I thought that the command module was overhead and that it had broken lock because of a maximum rate drive. The radar representative from RCA had indicated that the spec said it might break lock, but he didn't think it would as it went over the zenith. But because of the AG's indications, I thought that that's what had caused the break lock. Evidently, it had gone out the front field of view. Somehow, the time that it did break lock was just a short time after the time given us by the ground for the zenith passage. So I was fully expecting it to maybe acquire again. The gist of the whole thing is I don't think we had our AGs configured, and I don't think the ground was as helpful as we would have been had we run these sort of things previously in simulations and had a bit more training on them. Following that, we proceeded on in the checklist to execute another P-57. Let's see, now we started to do the P-57 and realized that this would be doing this too soon before liftoff. So it seems to me we had a time period where we were essentially standing by. Now the RCS check came in after that second alignment, didn't it? No. Okay, we did an abbreviated RCS check. And again, we got, since one of them was a cold fire check, again we got all the red flags coming on. Did an AGS calibration. Got the Ascent pad, and then at about 45-50 minutes before liftoff, called up the P-57 again and now did a landing site option at the TIG of liftoff. And now the torquing angles between this alignment and the previous were on the order of 9/100ths of a degree maximum. The gravity alignment had an initial error of 4 balls 1 and recycle the same thing. I don't have logged down what the star angle difference was, but it wasn't, it was probably on the order of 7 to 9, somewhere in there. It wasn't anything that made me jump up and down. But again, it was measuring the difference between gravity and a star, and of course doesn't really indicate how well you know the star position or how well you measured that, because it's relative to how well gravity was measured. We had an update in the position to leave the radar for Ascent, and we were instructed by the ground not to turn the radar on during Ascent. That included circuit breakers too, didn't it? Or was it just leaving it in the sloop?
Sloop.
We had circuit breakers in?
No, I don't believe we
I
did.
don't think we
we
did.
left them out.
Yeah, I think we did. This was to keep from overloading the computer in a similar way to what had happened the previous day during descent. I think that's unfortunate that we do have to deprive ourselves of one additional check for insertion confirmation. There was one more venting of the descent tanks, that liftoff minus 30 minutes. And here I have leave the radar and slew. It doesn't say anything about the circuit breakers.
I'm quite sure they were out.
Well, I didn't want us to use the tape meter in pings. Now that would have given us altitude and altitude rate out of the pings, right? So they didn't want to burden down the pings with doing that. And yes, we did, here I have on the circuit breaker card, leaving both radar circuit breakers open. We got the batteries on the line a little sooner because I think the ground thought that they might have cooled down a little bit more than their pre-flight information might have indicated. So we brought those on before TIG minus 30. Another change, we lifted off with the update a link and voice backup. Brought the VHF ranging on at TIG minus 15. Pressurized the APS tanks, and I guess it slipped my mind and perhaps Neil's too that the 10 crew had noted that they saw very little decrease in the helium pressure. At first it looked like we had about 100 psi decrease in tank 1 and 0 decrease in tank 2, and that was probably the worst thing we could have seen because we figured that just one tank had pressurized, and the ground, I guess, was a little concerned about that. If they were not concerned, I wish that they had given us just a little bit more comforting thoughts at that particular time, because we hesitated at that point, at least I did, in doing some more of the switch configuration, waiting for a confirmation from them. How are we doing on them? We haven't even gotten to item 1.
Yet.
Okay, we had another update from the ground instructing us not to go to AGS in the event that the engine didn't ignite, and not to make a manual start. We agreed that we would wait a rev. Everything worked according to the checklist. We just emphasize that we did use the Lunar align mode in the AGS and did not align the AGS to the ping, so it lifted off with its own reference system. It did have a ping state vector instead of the manual one that we could have given it in the LEM slot. The liftoff or at ignition, we waited until the last 2 or 3 seconds before almost simultaneously Neil depressed abort stage and threw the engine arm switch to Ascent, and I proceeded on the computer. And might have been a second after the T0 that any motion was detected. There was as I recall, an appreciable bang of the pyros. Fair amount of debris that was tossed out at the same time that we did detect first motion. It's fairly smooth onset of lifting force. There wasn't any jolt to it. A yaw that started gradually and was not abrupt either in its starting or ending. As a matter of fact, I really didn't notice it. I was looking, I guess, more at some of the gauges and the altitude rate, both in the pings and the ags. Neil was able to see. It seemed to take quite a while before we accumulated 40, 50 feet per second. The pitch maneuver, as seen from inside the cockpit, was not as in any way violent or very rapid as we were, or at least as I was expecting. And we seemed to have a good altitude margin looking down on the surface. It wasn't something that you'd describe as a particularly scary maneuver. I felt that we had adequate altitude rate at the time for that type of a maneuver. It seemed to me that right after the pitch over, I could still look out to the side and see the horizon. So out the window, we could verify what our pitch angle was. Before Neil picks up here, I'd like to backtrack up to one point on the camera operation. Camera was set up with the settings as in the checklist and inserted in, pasted into the checklist at TIG -2 was a notation of camera on. At that point I felt, since we were starting it at 12 frames a second, that it was too early to bring the camera on, and it got lost in the noise level at the time of average G coming on, and I would estimate something on the order of 30 to 40 seconds into the ascent was lost before the camera was turned on. And looking down at the time of the pitch over, I could see radiating out many particles of kapton and pieces of thermal coating from the descent stage. It seemed almost to be going out with a slow motion type view. They didn't seem to be dropping much in the near vicinity of the limb. I'm sure many of them were, but they seemed to be going enormous distances from the initial pyro firing and the ascent engine impinging upon the top of the descent stage.
During the pitch over, at the completion of the pitch over, you could easily detect by eye that a strong positive outward radial rate had been established, and there was no concern about attitude or falling back toward the moon. I observed one sizable piece of the spacecraft flying along below us for a very long period of time after liftoff, and I saw it hit the ground somewhere between 1 and 2 minutes into the trajectory below us.
It's very difficult to conceive of such lightweight particles like that just taken off without any resistance at all. It's easy to think back upon them and say that they would do that, but it just seems so unnatural for such flimsy particles to keep moving at this constant velocity, radially outward, just in every direction that I could see out the front window. I don't recall seeing any impact the ground, but there were sizable pieces.
Our velocity, altitude rate, and attitudes were consistent with the Ascent table that we were monitoring. Ags and pings were consistent in both attitude, as frequent cross-checks on the attitude indicators showed, and also in altitude rate, which was being read off the data and compared with the ping's value of H dot.
I think both of us were, well, let me backtrack a while, maybe a couple years ago, we had a simulation rigged up that tended to give us the sensations in the cockpit that you're liable to experience during LEM ascent. And we did this in the DCPS, and rotated us back and forth, and based upon this and many ascent simulations in the simulator, watching the rate needles pop back and forth and the air needles wipe back and forth, I expected quite a roller coaster ride of whipping back and forth, and nothing could have been further from the way it actually turned out. It was a very smooth, wallowing type of an ascent with far less excursions. Maybe the total rates were approximately the same, but the physical effect of them was not at all objectionable.
The rates and attitude errors, attitude changes were consistent with the simulations. The physiological effect of these was much more akin to the description presented by the Apollo 10 crew of their ascent engine burn. It was very pleasant. It had a Dutch roll mode, blow relatively low frequency, and it was not at all distracting toward your ability to monitor the ascent quantities that were significant. It was very pleasant and unusual trajectory.
It was quite easy to look out the window and pick up key craters as we approached them. We were keyed to look for the cat's paw or anything in the close vicinity to the landing site, and I did see several craters, none of which I could positively identify as being the cat's paw or in that immediate vicinity. The track looked good as we came up and went by Ritter and approached the crater Schmidt. The communications was excellent throughout the liftoff. We had a backup S-band angles at 3 minutes. We didn't need to change any of those. We did accomplish everything on the checklist. The balance couple came off. We were called on the start button at a minute or so after liftoff. Changed the frame rate of the film at about 3 minutes, from 12 frames a second to 6 frames a second. And then throughout the remainder of the trajectory, monitored the targeting quantities in Noun 76, looked at the countdown time in Noun 77, and then picked up the delta V to go in Noun 85 and cross-checked it back with VI to compare it with the trajectory. The numbers agreed very closely in H dot and VI. The altitude looked like it was coming right in on the targeted values, and the AGs agreed quite closely. The V to go in address 50 did differ a good bit from what I was reading in Noun 85. However, the AGS has slightly different targeting. It's targeting on a different comp cycle, and I attributed the differences that I was reading to that. The RCS quantity looked good, and the Ascent feed seemed to be operating quite well, and to avoid any rush approaching insertion, I elected to open the shutoff valves at about 700 to 600 feet per second to go, and I opened them one at a time, and turned off the Ascent feed and closed the cross feed. As we approached 50 feet per second to go, we still had good pressure in both Ascent tanks. And of course, that was one thing we were looking at right after liftoff to make sure we were feeding on both tanks. I think we inserted with 700 or 800 psi in both helium tanks. Approaching 50 feet per second to go, we disarmed the engine, and there was an auto cutoff. And let's see.
I think we the overburn was about 2 feet per second, and we nulled those.
I don't believe I recorded those. There was a certain amount of bounce to them, but since we didn't have anything over 1 or 2, I think, in Z component, we were able to get the X component down to near 0, I think 1 or 2 tenths, and let it go at that. The out-of-plane residual was small, on the order of 1, not over 2. The AG showed about 8 feet per second out of plane, and it was, as I mentioned, operating on an independent alignment. Verb 82, I recall, showed something like 47 mile apogee. We didn't have the radar to confirm insertion, but Miss Finn was quick to give us a good orbit, and the AGS agreed very closely with the pings.
And CSM gave us a
yeah, we got a range rate from the CSM.
satisfactory range rate, right?
Did we get the, I think we didn't, we got attitude hold and balance couple on. I don't think we reset abort stage and engine stop immediately. We, I think, held off on those. Disabled the TTCAs and designated the radar down out of the field of view in preparation for the alignment. Configured switches, stopped the camera, and progressed on with aligning the platform.
Okay, the initial platform aligned, I planned to use Acrux and Antares as the stars, knowing that Acrux, based on our simulations, would be close to the horizon. I had an alternate in case it was too bright down there. When I pointed auto maneuvered to Acrux, it was below the horizon. I couldn't see it. So I chose the first alternate was using Atria and Vega, Atria and Altair. So I went out of the program, re-entered P52, going into star 34 Atria, auto maneuvered to the point, and it wasn't in the field of view either. Both of those stars had been in the field of view in all simulations. So we terminated the program and re-entered at Antares, I think. Is that right?
37 and 34 is what I have.
37 Nunkie, which we knew would be in the field of view. Went in with Nunkie, and while I was getting marks on Nunkie, I had Buzz look up something that might fit with Nunkie to be a good second star. And I guess you came up with
Atria.
back to
Back to
Atria.
Atria. Yeah, it was up in the field of view at that
Okay,
point.
by this time, of course, we were stars were rising at a rapid clip, and we could go back to Atria and be quite sure it was in the field of view by this time.
Which one did you try first? Acrux?
Acrux.
Yeah, that wasn't in, and neither was Antares.
Neither was Atria.
Neither was Atria.
So we came back to Atria and got it. It was, the horizon was in the field of view during the mark, but we had satisfactory marks, got all zeros on our star angle difference, and very small torquing angles, as I remember, indicating that our pre-launch alignment was quite good.
Yeah, I think the largest one was in roll, and of course that doesn't affect the insertion as much. It doesn't appear to. The most critical one, I guess, is the pitch, and that had 3 balls 6-4. The one that intrigued me was the yaw, which will affect the out of planeness at insertion, and that had 406. And the yaw that we had before that was based solely upon the star alignment that we used before liftoff that went with the gravity. So it indicates that we had a very good azimuth alignment on the surface, and the gravity was certainly adequate to do the job as well as it did.
It was our intent to pick stars here that would be in the field of view and require a minimum amount of maneuvering and a minimum amount of time to get through the alignment, and would end up back in plane so that we would be just in a place where we could turn the radar on, designate the acquisition, and start getting marks so that we would have a good solution for CSI. Well, somehow or other, all this planning didn't work out on those stars. Why it turned out that our simulations did not correctly place those stars relative to the horizon, I don't know, but they didn't, so we wasted a little time and a little fuel.
Well, even at that, I think we did quite well, because it was about 28, 27 minutes before CSI, I recall, that we finished and were able to proceed with the getting the radar to lock on. That was accomplished without any difficulty. I think we got one noun 49 that we accepted. Before entering the program, we hit verb 95, then loaded the W matrix, and then enabled updates. And only one of them, only the first one, failed to pass the test, but it was significantly small as we proceeded on it. While Neil was doing the alignment, I queried the AGS as to what it thought of the insertion and what it thought the CSI maneuver would be, and it came up just based on the insertion vector with 15.5 delta H and 51.3 feet per second. The ground gave us an update of 51.5 feet per second for CSI with the 1 foot per second out of plane. I have the values logged down here for what the things came up with, and it eventually settled down on 51.5 also. Mike's solution agreed with the AGS, at 51.3, we elected to burn our solution without any out-of-plane component.
I was just amazed that we had 4 solutions within 0.2 of a foot per second of each other for CSI. That never happened before.
I might point out that for 2 reasons we didn't get a backup chart solution. One of them was the alignment took a little bit more time, not significantly so. I think we could have gotten a range rate at 28 and still gotten a good solution. However, the range rate that we were reading at that point was about 51 feet per second, which was way less than the values that were acceptable for the chart. In other words, it exceeded the limits of the rendezvous charts. And since we did end up with a 15-mile delta H and had a good nominal insertion, the only thing I can attribute it to is the command module not being in a circular orbit, having enough eccentricity to perturb the RDOT out of what it should have been. And I think this is another indication of where a late trajectory change was not rung through the whole loop to see what effects it had. Certainly we had nominal conditions, but the trajectory change did result in a range rate values that exceeded the ability of the chart to cope with them. How about the handling? It seemed to me that the nulling of residuals with the thrusters, even with 2-jet operation, there was a pronounced difference in translating with just the ascent stage. Each time you hit the thrust controller, why that vehicle was like somebody hit it with a sledgehammer and you just moved. No doubt about the fact that you had thrusters going.
Right, it's a very light and dancy vehicle, and it's true in attitude also. It's very squirrely, and the fact that we got 5 zeros on that alignment, I think, is just a matter of being consistent with all the other good luck we had that day, because it certainly was more difficult to do than the docked, than the unstaged alignment, where the vehicle was a lot steadier and we didn't get results that were that good.
It was sporty, there's no doubt about it, but it appeared as though with the automatic tracking and the wide deadband that the radar had, that it was not bouncing all over the sky. And I guess I anticipated that it might have been even sportier than it turned out to be, even though it was a difficult job doing precise aligning with it. I think the 10 mission indicated that they thought that they had a lightweight vehicle, but of course they had much more fuel on board than we did.
We did not find a severe a reaction to operating in Ping's auto, as had been earlier reported.
Yeah.
I can't confirm just what their configuration was in terms of the DAP and vehicle inertias, but our combinations made the vehicle fly quite comfortably in Ping's auto, and we used that more or less intermittently with Ping's Pulse. Did most all the manual flying in Ping's Pulse, and the remainder of the time Ping's auto. Burns in Ping's attitude to hold generally for 77.
With that lightweight a vehicle, it did appear as though it was not an easy task to make either X or Z axis. Of course, our burns were Z axis burns, but to make them, and at the same time you make them avoid having residuals of a fairly sizable number, at least a little less than 1 foot per second. It's quite difficult to terminate the burn and have zero residuals. We did end up with minus 0.2 plus 0.7 and minus 0.1. The ags agreed fairly close, again showing the greatest difference, I guess, in Z, which I think is attributable to the rotation of the burn when you load it into the ags. Got the radar locked back on again after, no, it stayed locked on throughout the maneuver. Started updating right on schedule, changed the W matrix down to the flight plan values, checked the numbers just before we changed it, and I think we could recall them if somebody wanted to. They were 1900 maybe, something like 15 and 3/10 milliradians. Then we started to work on the plane change, and what I did was make use of verb 90 and ask it for what out of planeness it has right now, which saves a little bit of time and not having to load in numbers. And we were coming up with things on the order of 1 mile at the most out of plane and 2-3 feet per second. The actual solutions that both vehicles came up with for the plane change, our first one was minus 3.2. Mike had minus 2.3, and our final one was minus 2.9. Being as small as they were, we elected to cancel the plane change maneuver and get more tracking data. The CDH, we took our time as computed by the CSI program for the CDH maneuver, voiced the maneuver to Mike to put in his P-76. And I guess when you're really getting precise, the question comes up, what do you do with residuals on the order of a couple of tenths? Do you take advantage of those or ignore them? We chose for anything that small that we didn't thrust out to ignore. The exception was out of plane, and we were handling that as a separate item anyway. Delta H varied between CSI and CDH. The solutions anyway varied from 15.3, 15.7. In general, the CDH maneuver decreased in magnitude. It had a much larger radial component, well, in all solutions, even in the ones that we had in the CSI program, it came up with 19 feet per second. It finally settled down to 18, which I think is indicative of the non-circularity of Mike's orbit. And we had no concrete evidence of that, really. Our procedures didn't call for finding out what his orbit was. The ground never did tell us what his orbit was and what we ought to expect for CDH. So I think we were kind of left on our own coming up to CDH as to what was an accepted burn. The data card says nominal is 4 feet per second H dot. We had 18. See, our solution.
4 is nominal for circular CSM1.
Yeah, and that's what you were supposed to have.
Yeah, I didn't.
See, I had components here for the AGS maneuver, CDH 9.1, 2.4, and 14.6. We, as per the procedures, loaded in the pings maneuver into the AGS, and I recall we did update the AGS with the pings before CDH. After CDH, things seem to be working so smoothly, and the delta H seemed to be so constant that I elected to start putting radar data into the AGS, and this seemed to be accomplished without any undue time burden. And I've got the data here that indicates what the AGS solution was for TPI with only AGS updates going into it, which I think will be fairly interesting to those people. In other words, it solved for a TPI, we burned the pings TPI, and I looked at the AGS residuals, which are a measure of the differences that it would have solved for, and they were on the order of 2.5, 3 feet per second. Everybody zeroed in on about the same maneuver for TPI. I guess in the LEM, you want to delay committing yourself, since you're picking the angle option, to saying exactly what time TPI is going to be until as late as possible. And unfortunately, this presents a burden on the CSM because he's got the time option. He wants to know what time we're doing it. And we gave him a time, and it changed by maybe 30 seconds. No, it changed by 15 seconds, so we ignored that time difference, and he used the previous time. The first mid-course correction was less than a foot per second. And I think we gave the values to the CSM, and he put them in external or targeting. Second mid-course correction, about 1.5 feet per second. We burned them in components. I guess it's up to you on angular rates that we picked up and range rates from that point on.
Had one moment of confusion about this time when I observed a significant non-zero lateral deflection of my cross pointer, which I interpreted as being a lateral line of sight rate indicating some out of plane velocity. And this was just a misinterpretation. However, I had the switch in landing radar computer rather than radar line of sight rates, so we were actually reading either AGS or PING's version of out of plane velocity at that point. I can't explain why that was indicated to be a large number there. It wasn't a real number. The line of sight rates were in fact very low, and as I remember, it was indicating something like 7 feet per second or something of that nature, which I doubt was a real number. Can't account for that.
The whole thing from once we finished the alignment was just a very leisurely running through what we'd done many times before, what we've been familiar with. It was a relatively simple operation. A rendezvous with the pings is a piece of cake as long as everything's working. when you start getting program alarms and the radar won't go in, why it gets pretty hairy, as happened during several sims, and you can really start chasing yourself around the cockpit. But when things work fine, it's simple. It does require close coordination with the other vehicle to keep the flow of information going back and forth. The ground didn't bother us at all. They were watching what was going on, and they called up and said they agreed with our CDH solution.
Braking was pretty much on the braking schedule, no problems there. The line of sight rates were small and easily controlled. The line of sight rate indicators from the radar operated correctly and gave us proper indications of line of sight rates. The line of sight rate indicator does not work like the simulator in several areas, most significant of which when the radar antenna goes from some line of sight rate back to 0, it does not do it instantaneously as the simulator. It takes about 5 seconds for the needle, for the radar to slow down, for the antenna to slow down to a stop, and for the needle to come from the peg back to 0. Both the sizes of the needle deflections and the rates at which they deflect are not correctly represented on a simulator. We stopped braking phase at 50 to 100 feet, and ensured that both vehicles were in a docking configuration. And at this point, we ran into a problem that we wouldn't have guessed pre-flight, I guess. The normal procedure for docking is for the limb to get in the, our procedure was the limb to get into station keeping position 40 feet out in front of the command module's plus x-axis, to pitch over 90 degrees, and so the x-axis are collinear, and then to yaw left 60 degrees so that we're in the docking attitude, and then let the command module dock. It was obvious when we got to this point in time, if we did that, namely pitch the limb over 90 degrees, we'd be looking directly into the sun. And we knew that would be an unsatisfactory lighting condition for docking. So the alternative seemed to be to roll the limb 60 degrees and then pitch down, and then you'd be in the same attitude. And you would have avoided the sun coming in the window, which we did. After arriving that attitude, discussion back and forth between the limb and the command module indicated that we weren't quite far enough, so I rolled a little farther, pitched over, and then waited, looking through the top window. We're asked to rotate a little farther by the command module to line up the docking aids and get the proper alignments, and promptly maneuvered the vehicle directly into gimbal lock. I wasn't aware of it. I was looking out the top window, not the front window. And was, gimbal lock. Well, there wasn't anything to do. There was no doubt that we were firmly ensconced in gimbal lock at that point. We had all the lights on. The DAP was not operating anymore. We had no control outputs. Clearly no CDU outputs were being processed, so we just put it in eggs and completed the docking in eggs. Now,
And I don't think the AGS is as good a system to dock in as the PINGs either.
this was just a goof on our part. We never should have arrived at that conclusion from from any series of maneuvers. However, that's how it happened, and it wasn't significant in this case, but it's never a desirable thing to do. There's nothing catastrophic about it here, but I'm sorry that somehow or other we hadn't studied the docking maneuver a little bit more carefully and recognized that there might be some attitude constraints in the maneuver that we hadn't considered.
The few times that we'd done that previously, we'd ended up approaching docking with the sun more along the line of sight to the two vehicles, and this was more our concern, I think, of arriving at the docking point a little bit late. If you arrive there a little late and the line of sight motion happens to be such, why the sun is going to be pretty close to where the command module was. But in this particular case, it was about 90 degrees away. After getting in that attitude of getting docked, why, in order to have a pings operating, why I gauged it to 0, or course aligned it to 0, and went through the quick alignment procedure and got the pings back in operation again, and figured, well, it's not a known rest mat, even though we told the computer it had a rest mat. But there were no maneuvers planned post-docking by the LEM. So in order to get both systems the same, I then aligned the AGs to the ping, so both of them lost their reference, but both of them were 0, 0, and as far away from any future gimbal lock as they could be, and that might have been a better way to operate anyway.
Okay, the rendezvous procedures from the command module viewpoint were about as well worked out, I thought, as they could be with the existing command module computer structure and with the degree of participation that's necessary by the CMP. I have always felt, and I still feel, that the system is designed in such a fashion that the CMP is too busy during the rendezvous procedure, and although I was able to keep up with the timeline quite well, I felt that I was devoting too large a percentage of my time to the job, and that I really was poorly placed to cope with any systems problems or any other difficulties or abnormalities that might have come up. Now, I don't propose any sweeping changes for mainline Apollo. It would be fruitless to do so, but I really think for future vehicles that the rendezvous should be something that is relatively straightforward and something which does not require literally hundreds of simulator hours to master the procedural aspects of it. I think as we get into these lunar exploration flights, the crew is going to be forced to devote more and more of their attention to what they're going to do once they've arrived, not just working out the procedures for how to arrive. And I really think that I don't know anything about the LEM, but from the command module viewpoint, with one man inside the command module, I think the procedures should be simplified, and if that requires a greater degree of automation, then I think we ought to have more automation. Getting specific about this flight, I had a solo book which combined various features of various other publications, the idea being that I wouldn't have to chase around the cockpit, but I would have everything in one cover. This concept worked well. I recommend it highly. The only funny I had during the rendezvous itself was that the VHF ranging kept breaking lock. I got a good lock on during Ascent, just as I had done during the simulations, and was very surprised when after insertion the VHF ranging broke lock, and I did reacquire, but from then on I would estimate that the thing broke lock 25 times during the course of the rendezvous. Sometimes I could immediately reacquire with the reset switch on panel 9, and at other times it was not possible to reacquire, and I would have to go verb 88 enter to lock the the VHF ranging data out of the computer, and then at some later interval I would get a good reacquisition and do verb 87 enter so as to allow that data to come back into the computer. It was possible for me to tell after a little practice whether I was going to get a good lock or not by listening to the tone during the lockup procedure. There are 3 tones, 2 of which are in the audible range, and if it was going to be a good solid lock, the tones would be very clear and sharp, just as they are in the simulator. And if it was not going to be a good lock, if the lock were going to be unsuccessful, then the tones sounded very scratchy and had a lot of static. And after the 3rd tone had completed its cycle, numbers would appear very briefly on the EMS, and then they would almost immediately go to 0, indicating the thing had broken lock. Go through my Ascent checklist. I use the technique of setting the mission timer in the lower equipment bay to the nominal LEM liftoff time, which was, according to my procedures, 124 hours, 23 minutes, and 25 seconds. And then at the instant the LEM lifted off, I started that clock running, so that I kept 2 times. The LEB time was flight plan time, and if I followed it, then I could, to a high degree of accuracy, tell you where I should be in my procedures book. On the other hand, I left the MDC clock undisturbed so that all updates and communications with the ground could be done in true and correct time. This is just one way to do business. It worked well for me. I practiced it in the sims. It was influenced by the fact that the digital event timers had a poor history of reliability, and that the digital event timers in spacecraft 107 had been replaced once and further had little funnies in them during tests. So if you trust the digital event timers to count down to burns, then probably my procedure is an unduly complicated one. On the other hand, it is workable, and I found it an aid in running through this, despite the fact that we were only a couple of minutes off nominal time. I have here some numbers on the breaking lock. I first got lock on during the latter part of the Ascent burn. It broke lock at 124 hours and 31 minutes. Reacquired immediately, broke a second time at 124:34, and broke twice thereafter in rapid succession. Okay. My out-of-plane solutions I relayed to the LEM. They were, after insertion, on the order of 1 foot per second. Had the LEM y dot minus 1.0. I had my own y dot plus 1.4. CSI solutions compared very closely with the LEM and the ground solutions. I think Buzz has recorded those numbers previously. I had myself at this time in an orbit of 63.2 by 56.8, which could explain some of the up-down component in the CDH solution, as well as some R dot peculiarities, which is the LEM experience.
What was it again?
63.2 by 56.8. And I had some eccentricity in in your orbit after CSI had you 49.5 by 46.1. So I think a combination of those two screwy orbits could explain lots of R dot dispersions and up-down components of
Yeah.
CDH.
Let me see. I asked the computer for what time we were going to get to apogee, and it was only a couple of minutes off of the CSI time.
Yeah, but you didn't know where his
That's right, yeah.
acronym was.
Mm-hmm.
90 degrees away.
Well, I don't think it's worth our spending a lot of time here trying to
No.
hash out these numbers, but I just mentioned them for the record. That's what they were. Plane change was not required during the burn. I still think that it's possible under some dispersed circumstances to have a large plane change required during one of these ascents or following an ascent from the lunar surface, and a plane change which might have to be done by the command module using the SPS. And this was something that had never been worked out, the procedures for it, and I did invent a procedure, and I don't think FOD didn't like it, although they didn't have any better procedures. So I would suggest that FCOD somehow come up with a procedure that MIT and FOD and all the other branches of the center agree might be used to allow the command module to whip around and make an out-of-plane SPS burn. Now, the one that I invented was sort of sneaky. It took P52, the platform align program, and told P52 to align the platform to a landing site which arbitrarily was said to be 35 degrees north latitude. And of course this is completely phony, but what it does, it has the effect of cocking the platform off 35 degrees in roll, so that when you yaw out of plane, either left or right, you'll go above the cherry or below the cherry because the platform has been rolled out of the way. And it worked well in the simulator, and I don't know what the objection to it is, but I just mention it as what my intent was, and I have a little procedure drawn up, and it was included in the Rendezvous book. If this is not a good procedure, then that's well and good, but it should have substituted for it something better, because you do, I think, need to have in your hip pocket some quick way of whipping that command module around 90 degrees and burning the SPS.
You didn't want to do it by just taking it 45 and asking for a preferred alignment?
But you have to get a new rest mat from the ground and everything else.
No, preferred. I mean,
Well,
you know what the burn is. That means you got to wait pretty late to do it, and that's probably not too good. Yeah.
Well, you mean where they load the rest mat desired registers from the ground? And you're talking about
No.
a nominal. You're talking about a nominal.
No.
Oh.
Preferred. In other words, you can
Okay.
you load the burn.
000
You load the
TIG.
burn
All
in
right.
P30.
Okay. All right. I see what you're saying.
And then go into
Yeah, you
P40, find out what it is, set the rest mat flag, and then go into.
Yeah. That's
52.
another way of doing it. You can do it that way as well. This P52 way was just quick and simple and dirty. Several times, another little funny I noticed was that maybe it's something that I overlooked in my training, or I don't recall right now, but after CSI, when I went to P20, P20 would not track the LEM, and in fiddling around I found that if I recycled the optic 0 switch, that it would track the LEM. Now I had, as a matter of practice, I always left the LEB in optics manual and optics 0 to 0. The reason you leave it that way is because of failure modes in the OCDUs, which are shared with thrust vector control if you're going to burn the SPS. So anyhow, best I can recall in the simulator, when you get back down into the LEB, all you have to do is take that optic 0 switch and throw it off, and P20 will immediately start tracking the limb. But
Do you have it in CMC?
yeah,
Yeah.
in CMC. But on 2 occasions it wouldn't do it, and I found if I took optic 0 back to 0 and then back to 0 off, it would track the limb. It's a little funny that I don't understand. It's as if there is a funny in that switch in regard to the optics power. When you first turn optics power on for the first time, then in P52 you have to cycle that switch back to 0 for the program to be aware that it has been 0, or otherwise you get into CDU difficulties. So maybe it's something similar to that. But anyhow, after CSI, when I went to P20, the sextant would not track the limb until I had recycled the optic 0 switch. And how I knew to do that, I don't know. It was just trial and error. Okay, VHF ranging, broke lock again along about plane change time. Broke lock again at 126 hours. CDH solutions we've already discussed. I had hoped to get some sextant marks after CDH, immediately after CDH, but prior to going into P34, and it was questionable because of the position of the sun. I thought that I could probably get 3 or 4 marks before sun shafting prevented it. I was wrong. I couldn't get any marks at all. So after CDH, I was able to get VHF marks only for quite a while there. In the meantime, I went into P34, and I made a note, very slow comp cycle the first time through on P34. And up until this time, the auto optics had been doing a smooth job of tracking the limb. I noticed here a few minutes prior to TPI, this smoothness disappeared, and it was quite jerky. I made a little note here: limb tracking jerky and sextant, and DAP excessive pitch thruster firings. It seemed like there was a little flurry of pitch thruster firings along about this point as well, which I don't have any explanation for. Everything progressed normally through TPI. It was really pretty along about mid-course time when you first started seeing the limb coming up from below. It looked like the doggone limb was riding on rails. There's absolutely no line of sight rate that I could see. It really looked great to see the limb coming up from the surface. You really, for the first time, had the feeling that some bitch was really going to get there in one piece. Mid-courses were very small. Braking was done entirely by the limb. I was completely passive, and that's all I have to say about the Rendezvous. Now the docking, we ready to go into docking?
Mm-hmm.
Okay. Docking, I did in CMC Auto, narrow deadband under DAP control. Neil made the crude alignments to get the correct side of the limb pointed toward the coas, and then I made the final adjustments. I estimated that I contacted the limb just about exactly dead center, and at a slow but adequate closing velocity, I would guess slightly in excess of 1/10 of a foot per second. Despite this fact, I couldn't tell the instant of contact. The LEM empty ascent stage is light enough relative to the command module that when the two vehicles touch, the LEM just sort of like pushing into a piece of paper. The LEM just, I guess, recoiled enough. They could feel it in the LEM, but I couldn't really feel it in the command module. I kept checking. I thought I was getting there. And when I finally was fairly sure I had contact, I looked up for the third or fourth time, and I did have 2 barber poles indicating that the capture latches had made. And at this time, I looked out the window, and the situation appeared static, and I threw the switch from auto to free so that I was in CMC free. Again, I looked out the window, having done this, and this is all going pretty fast now. I would say this is, maybe 3 seconds after contact. The situation again looked like it had previously, i.e. The 2 vehicles were statically joined together, no motion, and at that time I fired the bottle, and no sooner did the bottle fire than a gyration and yaw started between the 2 vehicles, and I'm not sure whether it's a result of the retract cycle beginning or whether it was the result of LEM firing thrusters toward me or some other cause. But anyway, at that time, this static situation became very dynamic, and a fairly large yaw excursion took place. I would say that relative to the LEM, I rapidly went out to about a 15-degree yaw right angle, and then I, at that time, took the CMC free switch and went back to CMC auto, which enabled the hand controller in rate command and minimum deadband, and I made manual inputs to try to yaw back over toward the center line. And there were a couple of other oscillations en route, smaller ones, and I can remember thinking, gee, I think we're not going to get a successful hard dock this time, and I'm probably going to have to let the LEM go and try again. When about that time, the docking latches fired, and we were in fact hard docked, much to my surprise. And I would guess that the time interval from firing the bottle to hard dock was in the vicinity of 6 to 8 seconds, as I guess is the time. I have no reason to change that, which is probably a pretty normal retract time. But things were happening fairly rapidly, and the oscillations that built up just almost, they began almost exactly at the time I fired the bottle, which was primary 2.
I guess I could add a few comments here from the other side. At the time we felt the contact, which really was difficult to feel. It was very low bump or sound and touch in the tunnel. We fired +X RCS and LEM as per the pre-flight plan, and shortly thereafter we also observed significant attitude oscillation. I guess it would be right roll as observed in the LEM primarily. We were in AGS, rate command, minimum deadband, and in addition, +X. As soon as the attitude deviation started, I left the +X off and called for Buzz to give me max deadband in the thrusters as soon as we swung out there, so we wouldn't be firing a lot of attitude thrusters. And then I took control and also manually maneuvered the vehicle back toward a collinear status, and about that time it snapped us in there and locked the latches.
I don't know. One of the things that I was in the habit of doing was this. I didn't like the idea of these two vehicles being joined together just by these three little capture latches, and the possibility of these dynamics developing. So I was in the habit of firing the bottle at the first time that it appeared that there was the two vehicles had been joined together and the situation was static. In other words, I never really gave these oscillations a fair chance to develop in my practice. Now, maybe a better thing to do is delay firing the bottle until you're sure that the oscillations are not going to develop, or until you've manually damped them out. On the other hand, this way, although it was sort of alarming there for a second or two, this way did work, and it was within the envelope. And I'm not sure if I had it to do over again what I would do differently. I think it depends on what caused the oscillations to get started. It could be the thruster firing of the LEM, or it could be some other cause. If it's the thruster firing of the LEM, then I think probably you ought to delete the thruster firing of the LEM. I'm not really sure you need that thruster firing of the LEM.
Well, I'm not
If
either.
on the other hand, it's some other cause, then the thruster firing of the LEM is probably not necessarily a bad thing.
It should tend to give some stabilizing effect to the LEM, but then when you're in rate command, I guess there are ways of looking at that also. You'd like to have some control system that's holding that LEM fairly close to what you want it to be, and that if it starts to move off is going to oppose that. And I think an automatic is probably able to catch that sooner than a manual is. And especially since you're looking up this way, it's pretty darn hard to maintain a real close position. So that argument says you ought to be in some kind of an automatic rate command system, but it's just that system that when you start inducing some oscillations is going to get you in a deadband or a limit cycle.
Mm-hmm.
Well, I think we have to admit that, again, this was one area that, in retrospect, we had given less thought than it probably deserves.
But
our simulators, none of our simulators are able to duplicate these kinds of dynamics. And we had some film work that had been taken, I think a McDonald study that had been done. And we'd seen those and observed what their recommendations were, and that's what was incorporated in our docking plan. But that
was the 7 seconds thrusting.
And that really was devised to ensure capture. I mean, to get the capture latches in. But I really suspect that everything that we experienced happened after the capture latches were engaged. And so those results of that study really weren't pertinent to this particular phenomenon. And nothing else is either. We hadn't experienced any trouble at all on your previous docking. That was just as smooth as glass.
It seems to me that it's not too good a mode to be working in, because you're tempted, if the thing starts to move on you, as it did, to touch the stick. All right, as soon as you do that, and then let go of it, you have now reset a new attitude that may not be what the combined systems are going to be happy with.
Yeah.
And if it's not, it's going to fire.
That's right.
And I don't know as you'd want to advocate a hands-off one, because you'd maintain that same initial attitude, but you could get stirred up there.
Well, I'm not sure that a lot of thought on our part in this area would have made the situation any better.
No, that's right. That's what I started to say a minute ago.
I don't think we got a tremendous amount of guidance out of the AOH or out of anybody's perusal of that and recommendations. It seemed to be kind of, however you want to do it. You can do it this way or this way. They're both acceptable means in the AOH. It seemed to me there were two ways that were acceptable, and this was with primary guidance control. Now, we didn't have primary guidance control because of the gimbal lock problem, but it still seemed to me that the book, I think, treated that subject a little lightly, and it was probably written for LEM active, wasn't it?
Yeah.
We gave the subject very little training time, but had we given it a hell of a lot of training time, I'm not sure that we could have come to any different conclusions than we did.
But it did bite us a little bit.
It's worthy of concern, because if you do prank something up, why the consequences are very damn time-consuming and nasty to have to go through.
Yeah.
You mess up that.
But it's, of course, we always make recommendations of changes based on things that get to us a little bit. This is one that did, and it's for one or another reasons, we didn't understand it well enough, or somebody hadn't thought about some of these particular dynamics, and I suggest that the next crew spend a little more time than we did in this area and try to improve on the procedures.
All the other dockings were done in things.
This was the same procedure from the command module viewpoint as had been used previously. The only differences were that the LEM ascent stage was considerably lighter.
The LEM control configuration was different.
Yeah, I just meant from a dynamics of the command module viewpoint. I don't know. I had a feeling that going to free under these circumstances was a mistake. That if I'd stayed in CMC auto and stayed in a half a degree deadband, that the CMC might not have been too smooth, but it would have fought this yaw oscillation. And no, that's not true either. No, I take that back. I don't know whether that's true or not, because all I know is that there was a relative motion between the two vehicles, and I'm not sure how much of it was command module motion and how much was LEM motion. I suspect that probably the great majority of it was LEM motion, being the lighter of the two vehicles.
Offhand, you don't have two good choices in deadbands. Half a degree seems to me to be way too tight for this kind of an operation, and 5 degrees is way too loose.
I don't know. I pass. It's just flag it as a problem. I sure don't have any solution. That's all I had on that. The latches all fired, all 12 of them, despite this oscillation, and from then on, everything was normal. Where are we?
Okay, we're at post-docking checks, pressurization, and tunnel operation.
Okay, again, when I went into the tunnel this time, I had that same strong odor of burnt material, and again, I checked everything very closely and couldn't find anything wrong. All the decals and checklists and whatnot, I think, are well worked out for the probe and drogue, and I was glad to see it work. I never had too much confidence that all that claptrap in that tunnel was going to work as advertised, but it sure did, and I was very happy to see the tunnel and probe and drogue and all that stuff part company and go along with the LEM. Let's see. Tunnel operations, transfer of LEM equipment and film. We went through a little extra operation, and this is something that we never practiced jointly, but it was my intent always to take the probe out and the drogue out and put those two items inside the command module. And I guess it was your intent to take them out from your side and put them inside the LEM. And I just happened to beat you to it. So it really wasn't very efficient the way I did it.
I thought you were going to do it.
Well, this
I
is
guess
one of
Neil
those
thought we
things,
were going to do it.
Yeah, I had in my mind that I was going to do it.
and the flight plan didn't mention it. It sort of, in retrospect, implied that you guys were going to do it, because it said, remove and stow tunnel hatch, and then it said notify LEM crew they could open their hatch, and it didn't mention the probe and drogue. So when I came to that, I thought, well, hell, they just left that out of the flight plan. And I said, matter of fact, I even called you guys. I said, you can open your hatch. And then I thought, well, that's ridiculous. They don't want to do that with a probe and drogue in there. So remember I said stand by one? And then I got the probe and drogue out and stowed them on board the command module, which just made for an extra operation, because then subsequently they had to get transferred to the LEM. So I guess, again, this is an area where we really, you couldn't say that we had smooth coordination. I mean, I knew how to do my end of it, and the LEM knew how to do their end of it, but we really hadn't sat down and discussed who was going to do precisely what in which fashion. Anyhow, you guys ought to talk about LEM equipment transfer. It went fine from my viewpoint.
The equipment transfer and cleaning, back contamination procedures were done essentially in the manner that was planned. Couple small differences. One, we decided that we wanted to bring the LEVA bags and the LEVAs and the EVA gloves back with us for post-flight examination and so on. And we brought the whole ISA, interim stowage assembly, with all its gear, transfer gear, into the command module. The intent was to unload that, re-stow it in the command module, and then take the ISA back into the LEM, and we didn't do that. We brought the ISA back in the command module with us. That's a 1 pound item or something. Essentially, we were able to get through that procedure about on the planned timeline.
Matter of fact, they were thinking about moving up TEI.
Well, as it turned out, our LEM jettison time could not have been moved forward a rev. We were,
Yeah, they talked
we
Because of
about it.
attitude?
couldn't have made it
Because of
really.
the attitude?
No, we just couldn't have gotten through in time. As
We
it
were
turned out,
not 2 hours ahead of time. We were maybe an hour and a half ahead of time.
They'd had, well, we could have done TEI earlier, but it would have crowded things, and it would have required a different attitude for LEM jettison.
Yeah.
Yeah.
And they didn't want to go through that rain dance.
I was concerned that it might take us a lot of time to clean the LEM, and I was concerned that we'd have a lot of free floating lunar dust in the cockpit, and going back to insertion, we really wondered at engine cutoff whether we wouldn't be completely engulfed in soot and be unable to take our helmets off for the alignments and things.
Wasn't that bad?
However, there wasn't much dust, and we couldn't figure that out
The
because
stuff
we
seems
sure
to stick to things and stay there.
thought we tramped a lot of it with us back into the LEM, but it didn't,
Not at all.
didn't bother us.
I wiped it up with my suit on the floor.
We did clean with the vacuum cleaner
And
as best we could. That vacuum cleaner has a very low suction, and so more time was required than we planned to do a cleaning job there, and we were afraid that it wouldn't be done to the degree of completeness that we had hoped for. We were able to clean the suits with the scrubbing motion to our satisfaction, that there wasn't a large amount of free contaminant in the LEM, and as planned pre-flight, we wore the suits back into the command module and stowed them there, restowed in the L-shaped bag after a period of drying them out, restowed in the L-shaped bag, and the LCGs were also stowed with the suits in the L-shaped bag. The suits were relatively clean, but they had a lot of residual smudges, black spots and
No, there's no
stripes
hope of
ground
getting that off.
into the suit fabric itself, which couldn't be cleaned.
The bags for the rock boxes, I think, could have some better labeling on them. We learned by going through the procedure that when you put the bag on, if you want the box to be mounted correctly in the command module so that 1G, or the G forces of entry, will push the material down toward the bottom of the box instead of the top, you have to, well, the lettering says which way the outside cover ought to go when you stow it in the command module, but nothing really tells you how you put the box inside the bag. You can put it either way, and we just had to learn that the way the lettering was, you had to put the bag on the box upside down to the way you'd normally think. In other words, the thin layer of the bag, the zipper went around the bottom to close it instead of around the top. So I think some more labeling would be in order, just to make sure that no one puts the box in the bag upside down and gets the G force in the wrong direction. I don't know how critical that is, but worth noting.
Stowage was as planned, plus we had a large temporary stowage bag completely filled with command module trash, food wrappers and so on, which was transferred into the LEM to clean up the command module volume. Talk about the separation, LEM jettison. Went as planned.
Was there never any intent for you to, in any of your briefings, to ever track the LEM after jettison?
No, that was never even discussed.
'Cause I can't understand why we left it in VHF ranging mode and left the track light on.
No, I have no idea. It was never, we never had a DTO, or it was never, my knowledge was never even discussed. I don't have anything to say about that. The
Separation was slow and majestic, and we were able to follow it visually for a long time.
the LEM held its attitude extremely well. I don't know what mode you left it in, but I thought when the explosive charge fired, the LEM separated quite abruptly, and I thought it would sort of, start it going ass over tea kettle, but it must have been in some good attitude hold mode, wasn't it?
We could watch the jets fire and hold an attitude as it went away.
So it was very stable. I don't have anything to say about that. The
Max deadband, ags that hold. It seemed to me that right at the time of separating, as the LEM moved away, I could see some cracks that had developed in the outer thin skin of the top part of the LEM. That gray material that forms an area around the docking cone. It held pressure according to the ground, and I couldn't see any other damage that had been accomplished by blowing the tunnel and letting the tunnel go with the LEM, other than these several little cracks. I don't believe we photographed that. Didn't see any. Maybe we did. Can't recall whether call that out or not.
No, we weren't set up to formally do any photography during that time period. We, like transposition and docking, we were LEM station keeping, when we first separated we were, and during the final rendezvous and docking we were, but this time I think we were photographed out. I don't recall that we took any pictures of it. The only comment I had is that the separation from the limb, that burn, was something that MCAT had changed their minds on a time or two. Originally it was going to be 1 foot per second horizontal retrograde, and then for some reason they wanted it 45 degrees up from horizontal, and they wanted a 1 foot per second retrograde component, or a total burn of 1.4 feet per second.
That's because one guy thought it ought to be this guy, and the other guy thought it ought to be this guy, and they compromised.
I don't have any preference one way or the other. It doesn't matter. It just seems like that's a fairly simple thing, and they ought to get their desire worked out early in the game and not have that be a last minute change. Because it just makes for last minute conversations about really what are unimportant things.
We didn't put the helmets in levers, did we?
No.
Looking back on it, I think it would have eased the stowage problem in the command module.
Yeah, but there was a reason for that, and that's that the levers and the EVA gloves were both awfully smudgy.
Yeah.
And the choice there was to leave them sealed up in the lever bags rather than get that soot out into the command module environment.
No, I mean doing that before taking them into the lab. Yeah. Once docking was complete and we were going to.
It would have been a possibility.
It wasn't real critical anyway. We had plenty of room to store those in a sleep restraint.
Okay, where are we?
We're up to TEI.
TEI was a beautiful burn.